Right, we're going to do lesson 55, complex fractions. Hopefully this is working. It doesn't look like it's working, but we'll give it a try. I have a new toy that I'm going to use to teach these classes, and I can just write right on my computer. So complex fractions are fractions within fractions. So here we have example 1. We have a fraction AB in the numerator of another fraction. Now on the bottom, we just have an x, but what we want to do is we want to make sure there's a fraction and a fraction in the numerator and denominator of the fraction. So what I want to do is make that into a fraction. In here. So I'm going to draw a line right here and put a 1 there. That makes it a fraction over fraction. That's what's called a complex fraction. Now you remember, what we're really doing is we're doing a division problem. We have a over b divided by x over 1. And if you remember from your math experience, the way we do this is we take the bottom, the denominator, and we flip it and multiply. That's how we do division. So we're just going to take the bottom fraction and we're going to flip it. It'll be 1 over x, and we'll multiply. So we get a over bx. And that is your final answer to doing complex problem. And they're going to get a lot more complex, but if you understand this, you'll be able to do the more complex ones. Let's go over to example 2. Example 2 is another complex fraction with a fraction in a fraction. Fraction in the numerator, fraction in the denominator. So we take our denominator. This is really 1 over y divided by 1 over z. So we flip the bottom. We flip the bottom fraction. And we will multiply. So we get z over y. And that is our final answer. Really pretty easy. Okay, down here, same idea. We have r over s divided by x over y, complex fraction. So we're going to flip the denominator and multiply. So y over x times r over s. So we multiply the numerator, we get ry over fx, and that is the final answer. And one more that's a little bit more complex. This time we have, in our numerator, it doesn't look like we have a fraction. In our denominator, we have a fraction. So we want to make our numerator into a fraction over 1 over x plus c. And we just do the same thing. We're going to take and we're going to flip the 1 over x plus c. So the x plus c is going to get on the top. We're going to keep our parentheses so we remember to use the distributive property over 1. And you can just leave the parentheses in. So we get a times x plus c. I'm not sure if they multiply that out in the back of the book, or you can leave it like this as a final answer. And that's it. And that's how simple it is to do complex fractions.